teacher Mugulumiza Noah, physics educator, can even call me physics facilitator as per the new curriculum. Now today, I have brought you good news. Have you ever asked yourself how planes fly? Have you ever asked yourself how MRI machines work? Have you ever asked yourself how builders construct different things like bridges and they are able to stand and withstand the large loads? Now, well, that is physics. Physics is life. Let's see how we can simplify this. Now, today, we are going to look at one of the physics chapters. This chapter is studied in senior 2, and this chapter is none other than pressure. We've time and again heard of the word pressure. I know some may be already familiar with it. Now, to those who already have some hint on it, and to those who have heard this for the first time, let us digest it and you internalize it to its end. Physics is life. Follow me up to the end and also inform other colleagues to join the live. You're welcome. Now, pressure is a physics term. I'm not talking about the disease, but we are going to talk about the pressure. It has components. It has a force and the area. Now, to make sense of a force acting on anybody, maybe they push you. Now, we have also to consider the area of contact to which the force acts. Because when someone pushes you, there is an area of contact between the hand and even the force he or she is using. Now, pressure, definition of pressure. Pressure is defined as the force acting normally per unity area. It is the force acting normally per unit area. Now, just from the definition of pressure, we can straight away try to come up with our own formula. Always urge my students not to cram these different formulae, but rather be able to derive even some of them. Because now you're seeing that it's force acting normally per unit area. So from the definition, we can ably derive our formula that the pressure is force over area. The word per mathematically means division. Now, the SI unit of force, just from the senior 1 introductory physics, it is measured in newtons, and the area, the SI unit, is measured in meters squared. Now, we can still get the SI unit from here, that pressure is now Newton per square meter, like that. This per is this division, the Newton is up here, and then per square meter, which is the area. Now, people can write using a forward slash, or you can just decide not to use the forward slash and you simply write Newton per square meter. You write Nm superscript -2. This -2 is per. You studied indices, they are shown that when this moves up, the negative is attached on the power. Now, that is the SI unit of pressure. However, just like you have your best dish, but there are also other different things that you love. Pressure happens to have got different units. Now, the first one is already Newton per square meter. Now, other units of pressure. One is pascals, and we abbreviate pascals as PA, capital P, small a. Someone can also measure pressure in atmospheres. atmospheres. You can also measure pressure in kilopascals. You can still measure pressure in centimeter mercury. You can still measure pressure in millimeter mercury. However, we are basically going to use Newton per square meter and a Pascal. Now, we have again brought in a new term, Pascal. A Pascal. Pascal was a physicist who came up with the idea of pressure. And so he named it after him. Now, a Pascal is pressure exerted when a force of 1 Newton acts on a body of area 1 meter squared. Is the pressure exerted when a force of 1 Newton acts on a body of area 1 meter squared. That is what we refer to as a Pascal. Now, we are going to look at some examples such that it can bring out the real sense of the topic, which is the pressure. Now, I'm going to consider, let's have an example. A man of 84 kilograms stands on ground floor with his area of shoe contact with his area of shoe contact as 0.042 meters squared. Calculate pressure exerted on ground. Now, this man, it's funny. This man is standing on the ground. Just assume you're also standing there. But this man is of mass 84 kilograms. Now, he's putting on shoes, but the area of contact of his shoes is 0.042 meters squared. Now, they want us to calculate the pressure this man is exerting on the ground. Now, it is simple. Just from our formula in our solution, when we try to summarize, we have mass of the man, which is 84 kilograms, and we also have the area of contact as 0.042 meters squared. Now, from the formula, I can simply say, recall that pressure equals to force over area. But when you look at the summary of what is given in the question, we honestly don't have the force. We are only given the mass. And then, this is interesting. You just have to recall some physics that you learned in senior 1. The relationship between force and mass of a body. Now, you were told that force and weight, they share the same SI unit, which is a Newton. So, when they talk of force or weight, you are supposed to put Newton as the SI unit. Now, recalling the relationship, when we say recall, that force F or weight, but in this case, allow me to use force, is related to mass with the formula force equals to mg, where m is mass of a body and g is acceleration due to gravity. Now, because this man is standing, so that means he's against the force of gravity. Now, force equals to mg. We get the mass of that man, then we multiply it with the acceleration due to gravity. This g here, it is given as 10 Newton per square meter. However, even if it is not given, you should now just note it in the main that this g is 10 Newton per square meters. If you don't use this, then you can use 9.81 Newton per square meters. It is also on your scientific calculator. If you have a scientific calculator, FX991 Casio, and you place constant 35, a letter G will just appear on the screen of the calculator. Then when you place equal signs, it will automatically bring 9.81. And when you round off this 9.81, that's when we come up with a 10. So let us first get the force of this man. We shall now say that force, this means that force is equal to mass, which is 84, then multiplied by G, which is 10, and our force will be 840. These are newtons. Now, we've finally got the force. The area is already given. Note, this is clear. Whenever you're carrying out any physics calculation, it is always good to calculate things when they are in their different SI units. In many cases, students tend to forget that. You already know that maybe the SI unit of length is meters, and then examiners or scholars, as per the new curriculum, they can just tease you, and then they give you units in centimeters. Endeavor to change to their standard international units. So now, when you look at the area given, it is 0.42 meters squared, which is already the SI unit of area. So that means we don't need again to change. Rather, we just have to punch back into the formula. Let's do that. So we shall have pressure equals to force that we've already got as 840, these are newtons, divided by 0.042, these are meters squared. When you use a calculator, here, you see that you get 20,000 Newton per square meter. Someone can just put pascals, PA. You can rate it like that, or you can say pressure equals to 20,000 pascals. Furthermore, you can even decide to write your answer in scientific notation. That is only if you are able to standardize this. So when we standardize this, we get pressure is 2 times 10 power 4. These are pascals. You can just read times 10 as exponent. So we can read this as pressure equals 2 exponent 4 pascals. Okay. Now, that is one of the examples of pressure. Now, let us have a second example. We shall not have so many examples for the interest of time, but you can always find these reading materials on our channel. Just subscribe and also encourage your friends to do the same. Let's have a second example. In this example that we are going to have, when the area is not given in meters squared, and we see what a physics learner is supposed to do first. We have an example that a car piston exerts a force of 20 pascals, across a cross-sectional area, across a cross-section area of 40 centimeters squared. Find pressure exerted by the piston. Find the pressure exerted by the piston. No. The question is, find the pressure exerted by the piston. The question, there was an error in the question. It is a car exerts a force of 200 newtons, not pascals. Yes, a car exerts a force of 200 newtons across a cross-section area of 40 centimeters. Then they want us to calculate the pressure exerted by the piston. Okay, let us still digest this question. It is always important, just like as I've told you earlier before. You need to first summarize and you see what is given, such that you now look for what is not given. So in the question, we see newtons, and when you see newtons, it is either weight or force. So we have force, which is 200 newtons, and also I'm seeing centimeters squared. Centimeters squared, that is area, because area, it is the only physical quantity whose units is in square. So the SI unit of area is square meters. However, it has other areas, millimeter squared, centimeter squared, say but a few. So we also have area, which is 40 centimeters squared. Now, we want to find pressure. So we have a formula that the pressure is equal to force over area. Good enough. The force is already in newtons. So this time around, we shall not again multiply by G. You only multiply by G when you have mass only, such that you now multiply mass times the acceleration due to gravity, which is approximated to 10, and you get a value for force. This time around, it's already in newtons. That means it is already calculated. However, it is also important when someone writes 200 newtons and they ask you what's the mass of the body, you just reduce a zero, and now you say the mass of that body is now 20 kilograms. Or you just use still the relation of force equals to mg, where you have force, you put 20 newtons, g you put 10, then when you cross a zero and the zero on the other side, you remain with 20 kilograms as the mass. So anyway is a way you can still go reverse. Let's go back to the question. Now, force is pressure is force over area. The force is 200 newtons, but the area is 20 centimeters squared. Now, this is where you tend to make mistakes from. You are seeing centimeters squared, but because you are in a rush, you simply now substitute and say, now pressure is 200 over 40 centimeters squared. And then you punch in these values on the calculator. This is totally wrong. I have told you, endeavor to change the units to their standard international. Now, we just come here and say, but area must be in meters squared. Recall that 1 meter is equal to 100 centimeters. Hope this is obvious to everyone. So we just still want to change the 40 centimeters squared to meters squared. Let us begin with this. 1 meter is 100 centimeters. This is very obvious. Now, what we do in the next step, 1 meter is equal to 100 centimeters. I'm going to put brackets on either side, so then a square. You see that when a square here, I get 1 meter squared that I want, and also square both sides. So when I square this side, I have also square this side. So I'll come here and say 1 meter squared. Now, when a square here, 1 squared is a 1, then m squared is m squared. Now, this equals, now we also have to multiply this side also. So 100 times 100, that is 10,000. also centimeters squared, because this square is affecting everything inside the bracket. So we get 10,000 centimeters squared. I can rewrite this, but beginning with this side, that 10,000 square centimeters is equal to 1 meter squared. How about 1 centimeter squared will be equal to 1 out of the 10,000. These are the whole of this stuff here will now be in meters squared. But we have 40 centimeters squared. So how about the 40 centimeters squared? Will now be equal to 1 over the 10,000, then times 40. The whole of this will be in meters squared. Use your calculator. This 0 will disappear with that. So you now remain with, it is now 4 over 1,000, which is 0.004 meters squared. Please and please use a calculator. Now, after changing our area to meters squared, we can this time round punch back into our formula. So we now say pressure equals to 200 newtons divided by our area, which is 0.004. It is in meters squared. So if you use a calculator, there, you see that you end up getting 50,000 newtons per square meter as our answer. As simple as that. It is not yet over. In physics, we tend to infinity. This is just an introduction. Please follow. Tell more of your colleagues to subscribe. We're now going to look at the types of pressure. We have 2 categories of pressure. We have maximum, and then minimum pressure. We have Mwangus Johnson, you're welcome. Jesse, you're also welcome. Jemima, you're also welcome. Pade Sebufu, you're welcome. Ruth Navada, you're also welcome. I think Brian, you're also most welcome. The last continue. Okay. Some have already given even the answers, which is very okay. That means you're following me. Okay. Let's now have the types of pressure after having looked at what pressure means and some introductory examples. Types of pressure. Types of pressure. I said we have maximum pressure, and then minimum pressure. One is the brother to the other. So if you can remember maximum, then minimum cannot miss out. Now we can just abbreviate this. We have, instead of writing the whole word, you can simply say P max, meaning pressure maximum. And then instead of writing minimum pressure, you can simply write P minimum, pressure minimum. Now, before we look at this, the formula, the different formula for each of these ones, we actually need to first bring out a day-to-day scenario. Now, I want to just pose the question to who are following. You get, just from your premises there where you are, you get a needle, and then you get a pen. 2 things. You have a needle, and then you have a pen. Now, me, I'm going to use my piece of chalk as a pen. Then just assume you have a needle. Use an assumption for the meantime if you don't have it. Now, use chalk to prick your skin like this. You can use a pen to prick. Why am I using a pen or chalk? Because it has a blunt surface here. It's not as sharp as that of the needle. So it has a large surface area of contact. So when I prick my skin using this chalk, I really don't feel any pain. Now, get a needle and try it. You just put it here and then apply some little force. Just exactly the force you used when you were pricking the skin using a pen. I dare you, you will not feel the same pain. The needle, you feel more pain. Why? Have you ever asked yourself why? You're going to see. You felt more pain, that is maximum pressure. You felt less pain, that is minimum pressure. What have you now noticed? That for you to have maximum pressure, then the area of contact should be small. That's why we use the needle and you felt more pain because of maximum pressure. Then, if you want to exert less pressure, then the area of contact should really be big. If I use chalk and I prick, it is like no work done, honestly. You don't feel any pain. Why? Less pressure is exerted on a large area of contact. That means we can just get the formula for each of these ones. So we are just going to say pressure maximum is given by the formula. Remember, pressure is force over area. That means I will simply maintain the force. Remember, I told you use the same force. The one you used when you're pricking yourself with the pen, and then the very force that you used when you're pricking yourself with the needle. So it is force over area minimum. That is pressure maximum. When you want to get maximum pressure, it is force over area minimum. The force should be the same because you use the same force when you were pricking. Remember that. That means we can now get also the formula for pressure minimum. You just reverse of force, the same force we used all over area. This time round, everyone now can say that it is area maximum. So also just recall this scenario. I don't know whether you've witnessed this before. Consider two people are putting on shoes on a smooth leveled ground. A smooth one is putting on flat shoes, and then another one is also putting on high-heeled shoes, those shoes that have high heels. Then you tell those people that run from here up to there, at least a distance on a smooth ground. Honestly, you now witness who will struggle. In my mind, that is food for thought. You also try it and you see. Now, the one who will struggle, it is because of the much pressure. The one who will sprint with a lot of ease because of less pressure. Let us look at some examples here. Now here, we are just going to consider a cuboidal box with different measurements. Let me sketch mine here. This is my cuboidal box. It of course has the length, width, and the height. Now let me assume length is 3 meters, width is 2 meters, and height is 1 meter high. Now you have this. This can be your tank at home or anything in the box where you put your plates, or a cupboard, anything of these measurements, or any measurements, but I'm going to use this. Now, our problem is they want us now to find the minimum and the maximum pressures that this box exerts when you put on the ground. Now, we want to find the maximum and minimum pressure. Let us begin with maximum pressure. P max, from our formula, P max, then it is force over area minimum. Now, let's take the mass of this box to be 5 kilograms. It's of mass 5 kilograms, such that why have I brought in the mass? Such that we can able get the force. Now, area minimum. Remember, area is in square units. That means we only have to multiply 2 dimensions to get square. But this cuboid box has 3 dimensions. 1, 2, 3, length, width, height. and we cannot multiply on the 3. Then that will not be area. It will instead be volume. So, but we want area. That means we only have to select 2 dimensions, 2 length, such that we get the area or the square. Okay. Now, to get area minimum, you also need to quote this, and also inform your colleague who is not on the live, or is to do this. Area minimum, it is smallest length times next smallest. I repeat, we have 2 meters, 3 meters, 2 meters, and 1 meter. Of course, in the normal sense of it, 1 is less than 2 and 2 is less than 3. Now, if we want to get area minimum, it is smallest length times next smallest. So the smallest is 1 times the second, which is 2. So we shall now multiply. If this is height, this is width. So width times height, remember it is meters, and time, this is also in meters. So we shall have got area which is in meters squared. So we shall now say force is equal to mg, then over area minimum, which is smallest times next smallest. So smallest is 1 meter times second smallest, which is 2 meters. So mass is 5 kilograms times acceleration due to gravity g, which is not in use now to you, it is 10. People, you can use 10, or someone can use 9.81. I showed you where it comes from. Just round off 9.81. When you round off to a whole number, you get a 10. So that's why we are putting a 10. So even if it's not given in the paper as part of reference, you should always just pick it from your minds. Now, over 1 times 1, rather 1 times 2, it's 2 meter times a meter, it is meter squared. Then 5 times the 10, that will be newtons, because we shall be getting force. So now, pressure max equals to 50 over 2. And this gives us 25. These are Newton per square meter. Okay, this is pressure max. Now let us really get pressure minimum. We shall just see this obvious that this is maximum and this is minimum. Maximum is the higher, minimum is smaller. P minimum is equal to force. The force is the same, remember? So it is 50 over area, but this time around it is over area max. So this is 50 over area max, which is largest site times next largest. So the largest is 3 meters times next largest, which is 2 meters. So it is 50 newtons divided by 60 meters squared. Now, someone with a calculator, if you have a calculator around you, we can try to get that answer. So we have a 50 divided by 6, and you will see that our pressure minimum will be approximately 8 1/3 or 8.33 recurring. You can rate up to 4 and say Newton per square meters. Let us compare. We have maximum pressure and minimum pressure. Maximum means big, minimum means small. So you see that maximum pressure is 25 newtons per square meters, and then minimum is 8. What has brought this 8? Largest area. What has caused this minimum, this maximum pressure? It is because of the small area. So basically that the bigger the continue. Okay. So we have understood what the pressure means, the types of pressure, and some simple calculations. We shall not finish all the examples. There are so many different examples. You see, a tractor can ably move on a muddy ground than someone who is riding a bicycle? Ask yourself, just the pressure. A tractor has those big tires, which will now exert less pressure. But a bicycle with that small tire will, of course, exert much pressure. That's why someone with a bicycle will a little bit struggle, and that of a tractor will just smoothly move. Okay? A hippopotamus can ably move on a muddy ground compared to a goat. A goat has a smaller area of its hoofed leg compared to that of a hippopotamus. So don't get stuck over there when you given two instances just to compare in terms of pressure. Okay, now we have factors that affect the pressure. In life, everything is affected by something. Now, pressure is also affected by a number of factors. However, before we go to that, we have pressure in solids and then pressure in liquids. I've been talking of tractors, goats, needles, and all that. When you categorize all those are all solids. Now, when they ask for factors that affect the pressure, particularly in solids, now you simply recall this, that pressure is force over area. So we just have got two factors that affect the pressure in solids. One, magnitude of force or size of force. Then the second one is cross-section area or area of contact, just from the formula. Don't cram, just understand this. Force over area, that is pressure. So factors that affect the pressure in solids, it is magnitude of force. Magnitude is the same as size. Then over area, so it is magnitude of force and then cross-section area or area of contact. Those are the two factors that affect the pressure in solids. Let us look at pressure in fluids. Now, we all know when we talk of fluids, a fluid can be a liquid or a gas. That is a fluid. But basically here, so we are having pressure in fluids. And I've told you that fluids, a fluid can either be a liquid or a gas, just from the senior physics. I don't want to go back into that. Now, we are basically going to concentrate ourselves on liquids. In this case, after having looked at the pressure in solids, so pressure also is exerted in liquids. Now, before I go any further, I want to bring real life example. You see, physics is life. Everywhere there is physics. How you move, for us to be able to see that is light, which is physics. You negotiating a corner when you may be riding or driving, anything. It is physics. Now, you all have water tanks at home. These water tanks, they are always raised up. They are never put on a flat ground. Have you ever asked yourself why? Follow and you find out. Okay. So we are going to consider a liquid of density rho. So this is our liquid. It is put in a container. This container has a cross-section area. This liquid has a height, we can call it h. Then this is area, the base area. Then it is of density rho. Density is can be abbreviated as rho. Now remember, a liquid only takes the shape of the container. Liquids are shapeless. When you pour a liquid in a cup, it takes the shape of the cup, and so happens to other shapes. So a liquid just takes the shape of the container. So it doesn't have any shape. So we're going to consider a liquid which is put in a container which is cylindrical. As you can see, it is cylindrical. It is of height h, and this liquid, say maybe it is water, it is of density rho. Now, we want to see which formula can we use to find out the pressure exerted on a liquid in the container. For it, it is not like that of the solid where we shall simply say force over area. So we are just going to derive our formula and we see how we can come up with a formula for pressure in liquids. Follow. Now, we shall first of all recall this primary formula, that the pressure equals to force over area, that is 1. I'm going to now expand this further. Force is mg over area. But now, okay, over area. But when you look at the area of this container here, it is cylindrical. P7, recall, area of a cylinder is pi r squared. Then the volume is pi r squared height. You multiply the base area, then times the height to get the volume. Good enough, we already have the density. Now, what we are going to do, this m is mass. So we are going now to recall two things. We had the relationship among these three quantities, mass, volume, and density. So it's what we are going to use. Now, recall that mass equals to volume times density. But volume, so this volume here, it is pi r squared height. Then density, it is rho as given here. Then area is pi r squared. Okay, let us substitute. We shall now have pressure equals to mg, but where we have m, I'm just going to put v times d. Now we have a g. So times another g here over area like that. So I'm going to substitute now the values for A and the values for D, for V. So we have pressure equals V is the volume, but this is a cylinder. It is a cylindrical kind of a container whose volume is found by base area times the height. So it is pi r squared height. That is V only times D. D is density, but we have given density as rho, so times rho here. Then times g, acceleration due to gravity. Volume pi r squared. D, density rho. G is right here. Then all over area. Area, it is pi r squared. Now, when you have that simple mathematics, you can see that pi r squared and pi r squared can just go for break or lunch. Then we only remain with h rho g. So we now have pressure equals to density rho g as our formula. Now, note this. Whenever you are asked to find the pressure exerted by any liquid, you just need to consider this. The density of the liquid to the height of the container in which the liquid is placed, and then the acceleration due to gravity. For you to be able to get water from the tank at your home, that tank has to be raised a little bit higher. The higher that tank is raised, the more pressure is exerted. And the reverse is true. This acceleration due to gravity, the moment you raise something up, that means it's against the force of gravity. So that's why we attach a G. Then this density is just a density of water. Okay, we can simply have a simple example here. If I happen to have a container here or a tank, it has water, it was of height 10 meters from the ground, then always the G may be given or may not be given. Then it has density maybe 20, because now density, it is mass over volume. So if it is mass over volume, then the SI unit of density becomes kilogram mass over volume. So volume is in meters cubed. So it is kilogram per cubic meters. That is density, because density is mass over volume. Mass is in kilograms, volume is in meters cubed. So that's the SI unit. So now we just say pressure now equals to rho Hg as our formula for pressure in liquids. So just substituting. This is density. We have 20 times h. The h is the height, which is 10, times the acceleration due to gravity, which is also 10. So when you multiply all this, you get 2 exponent 3. These are pascals. I told you earlier. You can standardize this, or you just write it locally as 2000 Newton per square meters. That is basically for pressure in liquids. Now, as we continue, I can welcome any questions, if any, and then we answer some of them. I think the sound is now improved. Someone is asking whether acceleration due to gravity affects the pressure. Yes, you wonderful here. Now, the factors that affect the pressure in liquids particularly, just like before, when we had pressure in solids, we said since pressure is force over area, then pressure in solids, the factors that were affecting it was magnitude of force and then the cross-section area. Similarly, for factors that affect the pressure in liquids, factors, we shall also get them from the formula that pressure equals to rho Hg. 1, density of the liquid. 2, height of the liquid. 3, acceleration due to gravity. Just from the formula. Those are the factors that affect pressure in liquids. So, the higher the height, the more pressure. The lower the height, still the lower pressure. So, it is just proportional to density and height. So, if assuming your tank, because we are problem solvers in the new curriculum, if your tank at home, you are facing a problem of low pressure, the tap doesn't bring water at a faster speed. So what you simply need to advise the people concerned is to increase the height of that tank. When they increase the height, even the pressure is increased, because it is one of the factors that affect the pressure in fluids. So the higher the height, the more pressure. And then even the density of water. Of course, much water will exert much pressure. So when you have much water in the tank, even when you try to open the tap down there, it will come out at a very fastest speed. That means the higher the density, then still the higher the pressure. Okay. Now someone is also saying if the liquids are pouring in different directions of the container. Okay. Pascal's principle, someone wants to know Pascal's principle. Okay. What of depth? Now depth and height are the same. So you can say height of the container or depth of the container or depth of the liquid. It's just from the formula. So don't get stuck or confused here. You can use height or depth. They are all length, because height is in meters, depth still that is in meters. So it's just length. Shouldn't confuse you. Okay. Master, why is someone swimming feels pain and difficulty in breathing while swimming in a pool, which is very deep? This is still pressure. Now, this is a very good question. The deeper you go in a well or in a swimming pool, the more pressure you feel. Actually, not far from now, I think in this very year, in America, there are some people who drowned and died because of the much pressure. It exerted on their boat and it simply crashed. No one knows now their whereabouts. So the deeper you swim, the more pressure you feel. Then the shallower you feel, you swim, the less pressure. I advise you not to swim so deep because you may face it rough. Because we've seen that pressure increases with increase in depth. So we are just going to now note the following. Actually, this brings us to some important terms to note. Let's follow. Okay. So we have terms to note or important notes. You can call it nota bene, NB. One note, pressure increases with an increase in depth. That's what some colleague was asking. Another note is that pressure or liquids find their own level regardless of the shape of the container, regardless of the shape and size of container. Now here I'm just going to look at, I think, one instance here, an experiment to show that the pressure increases with increase in depth. So we can just have this experiment, and from here you can even just experiment this locally within your means at home. Now, an experiment shows that pressure increases with the depth. The materials required, one, we are going to use local materials because we are in the new curriculum that are actually very familiar to you, and you can just get them within your environment. One, we need a bottle, water bottle, plastic water bottle. Two, we need a drill. You can use a knife. If the drill is out of your premises, then improvise with a knife. Then you need water, H2O. Now, arrangement of apparatus. We are going to arrange our apparatus, arrangement of apparatus. We are going to have this bottle here. You can, for you, can have a better one. Now, we have 3 holes here. You can call this 1, 2, or maybe let me use letters. This is A, B, and C. Then we are first of all going to feed now procedures. This is just a sketch. It's not that properly drawn. A clear diagram, you can always find it on our platform. Now, procedures on how you just experiment this simple experiment. Now, get your water bottle, any type, Renzoli, space, any water bottle, plastic. You're going to punch 3 holes on it, but on the same line, in the same line, vertically. One like here, which have named as A, B, and C in that order. Now, these 3 holes should be of equal sizes. Then you get cork, and you fix it in these holes here. Fix in hole A, B, and C. Why do you fix? We want our water not to first of all move out. Now, after fixing these 3 holes A, B, C with the cork, you're now going to get your clean water or water. and then you fill this bottle to its extreme top, like mine here, have filled it with water. Now, you're going to do this and observe. We are going to remove the corks that we had put in holes C, B, and A, but we are going to do this in the real time at the same time. Just remove all the 3 corks once, and then you observe the flow of this water. Now, it will be observed that water from hole marked A comes out fastest and powers furthest at a distance, seconded by B and lastly by C. What does this mean? This just concretizes the idea that the pressure increases with increase in depth. Now, this hole marked A, it is down here at the extreme end of the bottle. So that is the deep of the bottle, the deepest part of the bottle. So that's why there is much pressure. And you are seeing water pouring fastest and farthest, seconded by B and lastly by C. So for someone who asked me, why does someone feel more pain when he swims deeper? Because when you swim deeper, pressure increases with increase in depth. So the deeper you go, the more pain you feel. And the shallower you swim, still the less pain you feel. Answered. Now, we also have other experiments, but you can find all that on our platform. Thank you for your time.